I think I'm live, yes.
I think you're fine.
Well, shoot, here you go. Okay. All right, put your phones away, let's take some notes. Put your phones away, let's take some notes. Okay, so today is 5/19/22. Here we go. You didn't get notes either? Oh, I miss you. You guys distract me. You guys really do distract me. It's pretty easy. There you go. So, this is, all of these story problems are going to be type of ratio story problems, okay? And ratio is basically another word for fraction or proportion, okay? And so example 1 really is proportional. The more people that help, the less time it takes, right? We learned that if it's inversely proportional, that when one gets big, the other gets small. So Mr. Davies has a house that needs to be painted. If I hire Saul, the job could be done in 14 days. Okay, but I don't have 14 days. I need help. So then I go out and find Cole. So then I say, Cole, will you work with Saul so the house can be done in 10 days? Okay, Cole says, sure, I can do that. Yes, Michael.
Is this implying that everyone does an equal amount of work?
No, because it could be that Cole is a better worker than Saul or vice versa. We don't know. In fact, what we want to do is find out exactly that question. How hard a worker is Cole? Can Cole get the job done by himself faster than Saul or vice versa? Who's the better worker?
I think Saul is.
Okay, so let's see. So here's how I would say it. I'd say that, what they're going to do is we're going to take and add their jobs together. So we're going to have job, we're going to have Saul's work plus Cole's work equals 1. It has to equal 1 because we're only doing one job. So the proportion of Saul's work plus the proportion of Cole's work is going to equal one job, right? It's going to equal one job, get my house done. So we know that together they can get it done in 14 hours. No, I'm sorry, I said that wrong. Yeah, 10 days, right? So Saul's portion, he can just do his portions, he can do 14 hours in 10 days. Cole, 14 over T equals 1. Okay, so how this works is,
Wait, where'd you get the 14 hours?
that's what they do. I don't think I have 14 days. I don't have this right. This has got to be, oh my goodness gracious. Hold on. This should be 10 over 14. 10 over T equals 1. There you go. I did make a mistake. Sorry, guys. So together, they can do the work in 10 days. If you add their work, but this is Saul's proportion of the work. This is Cole's proportion. Now I have it right. So this is what they can do it together. This is his proportion plus his proportion to get the one job done.
I'm confused.
Yeah, how can I explain this better? So together, his fraction plus his fraction makes the one job, right? And together, it takes them 10 hours, right? Together. So 10 days. So his portion of the 10 days plus his portion of the 10 days for the one job. Okay? So this will work together. This is his part of the work plus his part of the work equals the one job. Now I'm explaining a little bit better, okay? So this is the amount together. So together, his portion of it to make the one job, okay? So hopefully I'm explaining this better now. So then what I need to do is to add these, I need a common denominator. So I'll multiply this one by T over T. I'll multiply this one by 14 over 14. And let's see if I can add those together, which I should be able to. So I'll have a 10T over 14T plus a 140 over a 14T equals 1. I have a common denominator, so I can add them. 14T 10t plus 140 equals 1. I'll slow down, let you catch up. Then I'm going to multiply, cross multiply, right, to solve it. Easy to cross multiply. So I have a 10t plus 140 equals 14t. Am I going slowly enough? I'm going to go minus 10t minus 10t. I'll have 140 equals 4t, right? Divide by 4, divide by 4. What's 140 divided by 4? I don't know. 140, clear. 140 divided by 4. And I get 35. So it looks like actually Cole's not a very fast worker at all. So it's going to take Cole 35 days to do the job. But, you know, with his help, we get it done a little bit faster, okay? And you'll see one of these on your test on Wednesday, okay? Hang on to these notes, right? Okay, and then on the back side, okay, Mr. Davies took a bike ride this summer in Wenatchee. It was a windy day. He rode 16 miles into the wind, then turned around and rode back 60 miles with the wind. He can normally average 12 miles per hour. Okay, that's not too bad, right? How fast was the wind blowing? Okay, so we're going to set it like this. We do know that it's a rate time. Okay, we know that we can start with distance equals rate times time, right? We can just start with that. We know that we've got a rate of 12 miles per hour if it's no wind. We've got some time and we've got some distance, so let's see. If I set up, what I'm trying to solve though for is my time. I want time. So if I solve for time, it's distance divided by rate, okay? Because I'm really looking for time. I like to use a chart for this. I think it's easier to see if I use a chart. So what I want to do is solve for time. So I backed up. I knew it was a rate problem. Distance equals rate times time. And I need to find the time, so I know the time is really my distance divided by my rate, right? So my chart, I've got distance equals rate times time. I'm going to have with the wind and against the wind, okay? With the wind, against the wind, right? Well, the distance is 16 miles, right? I know here it is, 16 miles, right? So now the distance is 16 miles. And the rate, well, I can go 12 miles an hour, but with the wind, I'm going to go faster, right? My rate's going to be faster. On the way back, it's still 16 miles, but when I ride back, the wind's going to slow me down. So my wind is going to subtract my rate. How am I doing?
Wait.
Okay. Yeah, I
I
will.
thought on his way back it was with the wind.
Oh, I might have this backwards. Okay, it's all good though. It won't matter. Giselle, it won't matter. You agree with that?
Yes.
Okay. Now, the time. The time there and the time back. Since the distance is the same, we know that time is equal to distance divided by rate. So my time, though I don't know my time there and back, I just know that together it's 2.5. I know that with the wind it's going to be 16 divided by 12 plus W, okay? So my time with the wind is 16 divided by my rate. Okay, my time is 16 divided by my rate, and then against the wind, it's again my time is 16 divided by 12 minus W, or my distance divided by my rate. So my rate's slower because I'm going against the wind. Now the round trip, let's look at the round trip. The round trip is going to be with the wind, against the wind, or do I have that backwards? Into the wind. So it's going to be with the wind plus, how's that, Giselle, better? against the wind, and I know for sure it's going to take me 3.5 hours, okay? So I got time with the wind plus my time against the wind makes my total time, right? I mean, the whole trip there and back was 3.5 hours, okay? I took a road trip, I left my house, I turned around, I came back home, 3.5 hours, okay? So the time is time 1, which is my time with the wind, is a 16 over my 12 plus W. So my time is my distance divided by my rate. I'm going faster with the wind, plus my time against the wind, which is 16 over 12 minus W, equals 3.5. Okay, how am I doing? Well, I'd like to be able to get a common denominator because I have to go back to what we learned. So the common denominator, let's see, I'll multiply this fraction by 12 minus W over 12 minus W. I'll multiply this one by a 12 plus W and a 12 plus W. And the 3.5 over 1, to make it easier, remember how I crossed out the denominators? To make it easier, let's give them all three fractions the same denominator, so I can just get rid of them, okay? So I also want to multiply my 3.5 by my 12 plus W, 12 minus W, top and bottom. All right? So let's see. I have a common denominator all the way through. And Juan, this was your question. How can I just scribble them all out, right? And I'm going to show it again. So to make this problem easier, if I multiply everything by a 12 minus W, it'll cancel. It's cancel. I take everything right here and multiply by a 12 minus W and a 12 plus W over 1. This will cancel here and here. And same thing over here, I'll multiply by a 12 plus W and a 12 minus W over 1. This will cancel all of that. It's just a trick. It's a great trick because it's mathematically correct. But what happens is now all of a sudden there's no fraction. It just gets rid of the fraction, okay? So let me do that. I'm going to multiply by the common denominator, and it just gets rid of the fraction, okay? So if I scribble out my fraction because I multiply by my denominator, what am I left with? Well, I'm left with well, it's 16 times 12. 16 times 12 is 192 minus 16W plus another 192 plus a 16W equals 3.5 times 144 minus W squared. If you multiply this out, you'll get 144 minus W squared, okay? Kind of a mess up there, okay? Okay, so let's see what I have. I got 192 plus 192.
This better be like an extra credit one.
It is, actually. It is. 384. It is your extra credit. These two cancel, right? And then this is going to be, I don't know, what's 3.5 times 144. But aren't you glad you get a chance to see it? So you can at least say, yeah, I'm going to try the extra credit. Or you say, heck no, I'm not going to try that extra credit, right? And then minus a 3.5 W squared. Okay, how am I doing? I'll back up and stop for a second, okay? Okay, now I'm going to keep solving. I'll go minus 504, minus 504. Oh, let's see, what is that? 384 is 120 equals negative 120 equals negative 3.5 W squared. I'm going to divide by negative 3.5. Okay. And I get about 34. I get about 34.2 0.28 blah 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 equals W squared. I'll square root both sides. Square root that answer. And about 5.86 miles per hour is the wind. How's that, huh? Okay, let me stop the recording. And you're right, this is a great extra credit problem, isn't it? You agree? So if you have good